Yes, hello everybody from me. My name is Elsa and I work in Estonia at the Center of Estonian Rural Research and Knowledge. And I would like to present some of the map applications we have developed here with our small working group. So the project is about creating map applications. One of the first applications was about crop suitability. Another was for soil erosion. And then came a map application for soil texture, soil moisture regime, and then a very specific application for soil sampling. The main idea was to use the large-scale Estonian soil map in an effective way to translate it to a more easily understandable format for farmers, for researchers. I will show you later on the maps in detail. To determine the duration of the project is quite difficult. In some ways, this is ongoing all the time. We are thinking of new applications and we are thinking of updating the applications. But as the previous presenter said, it's the field works, the experiments. That's what takes time to collect data. So in that perspective, some of the map applications, like for soil, for crop suitability, we use data from very long time ago, and to update it, we are doing field experiments right now. So it's a very long-term thing. The funding, it's budget-based. We don't apply for any specific projects for it. We do this as part of our work. Innovation, well, the main idea actually was to translate the data from the soil map, which is quite difficult to understand, for a more easily understandable format. And so the innovation part is quite a tricky question here, to take something what has been done and translate it to a new way. Is it innovation or not? It's up for you to decide. All the map applications are freely available, of course in Estonian, as they are more intended for local users. I will show you here quickly them too, and then we will go to the actual applications. For this crop suitability, this is mainly based on soil data, the soil types and soil textures. You see, this is the base table under this application. We have different soil types in this column. We have soil textures in this column, and then we have these points for each of the crops, for wheat, for rye, for lupins, for different things. 10 meaning the best suitability, and 2 and 1, 0. These are these areas are not suitable for growing these crops. And you can see also here that these data date back to 1973. They were updated in 1994, 2002, and as some popular crops right now, like rapeseed, are not in this table. We are doing field experiments right now to get some updated information about these crops too. Basically, you can see from the map application how for each crop, how the area or fields are suitable for growing them. The green color represents good suitability, and the purple colors show very bad suitability for growing, example, wheat, for lucerne, for lupins, and for potatoes. Another application is for soil texture. We can see the texture classes on the legend with different colors. Then on the left side, you see how the distribution of texture classes are on the field, and then how the area coverage of this specific texture class is. Then we have application for soil erosion. This was calculated based on USLA erosion model. And here there are different layers, like for potential erosion, erosion on fallow land, erosion on winter crops, erosion on summer crops. And then there's application for soil moisture regime, showing us if the soil is moist, is it with normal moisture. And I'd like to show them now to you on our website. So this is our institution website, and each map application has its own direct link to the application. These are based on Spectrum Spatial Server applications, and let's see when it loads here. This is now this crop suitability application. You can see orthophotos are here in the background. When I zoom in, then I can choose from up here to have a soil map also shown in the background. I have to zoom in more, and these are the areas of our soil, different soil types and textures. Now let's say I choose from here some kind of crop. Let's say I will take wheat from here, and then now it shows me with colors where is suitable to grow wheat and where is not. For example, here in this green area, it's good. The suitability is good, but for example, if we go here in the right side, then it's bad, and it's a quite logical why it's bad, because this is a peat soil and it's not reasonable to grow wheat on peat soils. So this is really the base really lies here in the soil map. All the areas are differentiated by the soil textures and soil types. So this is a handy tool for a farmer to go to our website and go and search for their own fields. You can search here by this field numbers or cadastral units, the areas, the fields, and you can look, okay, I want to grow this year lucerne in my field. Let's see if it's suitable, if the soil is suitable. And there are, for example, here entire field which is not suitable for growing lucerne. And then I could make decisions that where it's optimum to grow them or not. Of course, you can grow them in the areas that are not suitable, but you have to consider then you have to put more inputs into the soil via agrotechnology. Another example I wanted to show you was with this erosion. So this is the potential erosion tons per hectare per year, and it shows that the blue shows that there is no erosion from this specific place, but there are some erosions inside the field. Here it's quite a lot, and it also is a good, very good map for indicating the erosion potential in Estonia. Um, so all the map applications look like this. You can search by fields, by cadasters. You can change the underlying maps. You can click for different options here. Do you want to see erosion on winter crops, etc.? So it's quite easily usable, and a nice tool for helping to make decisions on crop growing. And challenges, well, the biggest challenge was trying to find the code for translating the data for computer-based application. So we figured out the system of, especially for the crop suitability, how it's possible to take into account all the soil type information and the texture information in it. The initial tables were separately for grasslands and for crops. So this was the most time-consuming part in that work. For soil erosion, of course, running the erosion model, collecting all the input data for it. These are the challenges, and of course, this was the first time uh, our GIS person here tried to get this server-based application, this Spectrum, even to work. So all the first steps and problems, they had to be solved in the beginning. We would do nothing differently. We have no special complaints about this work we have done so far. We would like to, of course, make updates in the future based on these field experiments. Then we are currently working on some updates on Estonian large-scale soil map. If the soil map is updated, then we of course have to update the information in the web application. And if the software enables, we would like to offer in the future to enable a farmer to look at the location-based statistics. For example, you can choose via field or cadastre this information about your field. Right now, it's more like soil map area-based information, but you cannot look exactly, take out the results exactly for a field. So that's shortly, that's it. Thank you very much, and I look forward to the discussion.